All right, here we're going to learn about solving two-step inequalities. When I say solving an inequality, I really just mean get the variable completely by itself. So, an example, y is greater than 5. That's a solved inequality because the variable is completely by itself. We have something on the opposite side of the inequality sign, but the variable on the left side is by itself. So that's our whole goal here, to just isolate the variable. And to do that, we're going to be using inverse operations. So you're going to see examples like this. 2 times y is greater than 5. And you want to get rid of that 2. You want to get the variable completely by itself. So right now, this example is not solved because the variable is not by itself. To solve that, we would try to cancel out this multiplying by 2 by using the inverse operation or the opposite operation. When I say inverse, I really just mean the opposite. So addition and subtraction are opposites, multiplication and division are opposites. So right now, that's multiplication. To cancel out that multiplication, I would use division. That's the inverse operation. And the entire purpose of this is to isolate the variable. We want to try to get that variable by itself. So on these two examples, we see that we have x minus 5. This is the operation that's happening. That x is, we're subtracting 5 from it. We're going to do the opposite of that operation. So right now it's minus 5. We're going to do the opposite. We're going to do plus 5 to cancel that out. If you do it on one side of the equal sign or the inequality sign, to keep this balanced, we have to do it on the opposite side also. So we're going to do plus 5 on the opposite side also. The plus 5 on the left side is just to cancel out this minus 5 and get the x by itself. That's the whole purpose there. If we do it on one side, you have to do it on the other side also. So there we would add 5 to this negative 32. The sign comes down, and then we do this addition and get negative 27. On the second example, the operation that we see right now is division. It's x divided by 3. So we're doing the inverse operation. The opposite of division is multiplication. We're going to multiply by that exact same number. So right now it's dividing by 3. Here we're going to multiply by 3. If you do it on one side, just to keep this balanced, you have to do it on the opposite side. So we're also going to multiply by 3 on that side. The multiplying by 3, dividing by 3, they cancel each other out. That's exactly what we want. That gives us just the x by itself. And then we multiply by 3 on the opposite side, and we get 42. The sign just comes down. We just rewrite that right in between. So x is bigger than or equal to 42. And really, it didn't change anything. That's why we multiply on both sides. We're not changing anything. 42 divided by 3 is greater than or equal to 14. We also know that this is really saying any number that's bigger than 42 also works here. So we could say 43 or 45 or 47 divided by 3 is also greater than 14. So we didn't change anything about the inequality. Any number that we are talking about here, any number bigger than or equal to 42, also works in the original problem. All right, so this is just working through each of these problems step by step. It's going to be more than just that one step like we saw in those first two examples. First thing I want you to do is draw a box around the term that includes the variable and the sign. I actually want you to say and the sign, especially when the order is different, but the sign is going to be a big part of that variable term. So here we're going to box that 2y. And the reason is really just a visual for what we're going to keep after we do the first step. Like, that's what we're going to do last. We're going to deal with the stuff in the box as our last step. The stuff outside of the box is going to be our first step. We're going to use inverse operations. We're going to use opposite operations to cancel terms out and move them to the opposite side and isolate the variable. Our whole goal is to get that variable by itself. Our final answer is always going to be a full inequality. So we're not just going to write like this one saying x is less than negative 3. You don't just write negative 3 because it's all the numbers that are smaller than negative 3. So in this one, we're showing these inverse operations. We box the 2y. That's just a visual to say that we're going to deal with that later. For right now, we're trying to cancel out the other operation, which is this minus 4. To do that, we add 4 on both sides. The minus 4 and the plus 4 cancel each other out, which is exactly what we want. We're trying to get that variable by itself, just canceling these things out one step at a time. That's our first step. So the minus 4 is gone. Now we just have the 2y. On this side, we're actually just adding there. Negative 12 plus 4 gives us that negative 8. Now we have this multiplication. The opposite of multiplying is dividing, so we're going to divide away that 2. Divide by 2 and multiply by 2, those operations cancel each other out. That's why we're using inverse operations to get rid of that. That comes down as just the variable by itself, or just y. And then if we do it on this side, you have to also do it on that side. We divide negative 8 by 2 and get negative 4. That is our final solution. You're writing that whole inequality as your answer. One thing that you do really have to remember, if you multiply or divide by a negative number, you actually flip the inequality sign. It changes the relationship between the variable and the number on the opposite side. So here, we divided by a positive 2, so we didn't need to do that. It doesn't matter if this is negative. We divided by a positive 2 on both sides, so we don't flip the inequality sign there. You're going to see on example 4 that we will flip that sign. Let's try example 3 first. So my first thing is just box that 2x. It's really just to show that I'm going to keep that intact for right now. That's going to come down, and I'll deal with that a little bit later. For right now, I'm going to cancel out that minus 7. That's my first step. Canceling out the minus 7, I'm going to plus 7 on both sides. Minus 7 and plus 7 cancel each other out. If I do it on that side, I also do it on this side, so negative 3 plus 7 gives me a positive 4. And I write that inequality sign in between. That just comes down also. Now I want to get x completely by itself. So right now I see that it's being multiplied by that 2. The opposite of multiplying is dividing, so I'm going to divide by 2 on both sides. Those cancel each other out. That gives me x all by itself, which is the whole goal here. The sign comes down, still greater than or equal to, and then I divide 4 by 2 to get 2. So that is my final answer. X is greater than or equal to 2. So that's saying any number that's 2 or bigger, 2, 3, 4, going on forever, would be a solution to this inequality. So let's say I put 10 in there. That's saying when I solve this, 2 times 10 minus 7, that's going to be bigger than or equal to negative 3. It's any number that's 2 or bigger. That's really what this is saying, that x can be a number that's greater than or equal to 2. All right. Number 4 is written in the opposite order. The x is not the leading term. If you'd like to, you could rearrange this. If you really want to, you could put that negative x in front, the plus 4 on the other side, and then write greater than 10. I'm not going to. I'm just going to solve it as it is. But I think this highlights what we have to do as our first step. There, I think it's really clear that the operation with that 4 is addition. Here, I don't think it's that clear. But it's a positive 4. So I'm going to actually box my term first. That negative x or negative 1x, that's going to stay intact until the next step. But for right now, I'm trying to cancel out that 4. So you might be thinking I have to add because I see subtraction here. But the subtraction is really talking about the x. It's really a coefficient of the x. It's really that there's a negative 1 in front of that x. The 4 is what I want to cancel out first. And to cancel out a positive 4, I can't add another 4. I'd have to subtract 4. You want to do the opposite of a positive 4 there. So we do minus 4 on both sides. That's going to cancel out. The negative x comes down. And if you do it on one side of the inequality sign, you got to do it on the other side also. So we get 10 minus 4, which is 6. Now I'm going to rewrite this with that coefficient. I'm going to write negative 1x is greater than 6, because that's telling me pretty clearly that that's multiplication. It's negative 1 times x there. So to cancel that out, I'm going to divide by negative 1. Opposite of multiplying is dividing. That's why I'm dividing there. Negative 1's cancel out. You multiply and divide by it. It ends up as just 1, which is just not meaningful there. 1 times x is just x. So it leaves me with just x. And on this side, we divide and get negative 6. We divided by a negative 1 on both sides. If you multiply or divide by a negative number, you have to flip the inequality sign. So instead of pointing this direction, it's going to point that direction. So x is actually less than negative 6. So any number less than negative 6 is a solution to that inequality. So sometimes you might be asked about a graph, or even just solutions. You might have to pick numbers that actually work in that. So you pick like negative 10, negative 8, numbers that are less than negative 6, or you might have to match it up with a graph like we see here. I'm going to start by flipping this entire inequality. I would much rather have my x on the left side to start. So I'm going to take this expression and bring it over to the left. I'm going to take the 13, bring it to the right, and I'm going to flip the sign. I'm not changing anything. I'm just changing the way that looks. And now I'm going to solve. I'm going to first box in my negative 3x and cancel out the other part of this, the other term, which is that plus 1, by subtracting 1 on both sides. Plus 1, minus 1, cancel each other out, leaving me with just the negative 3x is less than or equal to 12. In my last step, I have multiplication here. To cancel out multiplying, I'm going to use the opposite operation. I'm going to divide by that exact number. You divide by negative 3. So you get x is greater than or equal to negative 4. When you divide by a negative number on both sides, the sign flips. So now it becomes a greater than or equal to symbol. So now I'm trying to match that up with a graph. They all start at negative 4, so that's not really super helpful. But this sign is going to tell me what my line is going to look like and whether I'm going to have an open circle or a closed circle at that spot. Well, it's saying x is greater than or equal to that number. So it's definitely going to be a closed circle. Anytime you see this line underneath, it's a filled in circle. So that's telling me it can't be this one and it can't be this one. Because that's saying it's strictly something that's less than or bigger than it. It can't be negative 4. This line is saying that it could equal negative 4. And it's saying that x is bigger than or equal to negative 4. So it's talking about all the numbers greater than negative 4. So there our answer is D. It's a filled in circle at negative 4. And it's all the numbers bigger than that that are shaded. We got a couple more examples, and we're going to do all the steps that we need here. We're going to graph them and then pick some solutions. We're going to pick all the solutions that we see, all the numbers that make that inequality true. Okay, so on the front, I described this as boxing in the term with the x. Here I'm going to expand that a little bit. Really, I'm going to think about the first operation that's applied to the x. I'm actually just going to box the entire top part of this fraction to say that that's what I'm going to deal with later. I'm going to start with the other part. So right now, it's showing that I'm dividing by negative 3. I kind of covered it up, but it's saying that's all being, sorry, I said negative 3, I meant positive 3. That's being divided by 3. To cancel out that dividing by 3, I'm doing the opposite of that. I'm going to multiply by 3. Dividing by 3, multiplying by 3, cancel each other out. Leaves me with just x minus 4. The sign doesn't change. I'm multiplying by a positive number on both sides. I'm going to keep the sign the same and just multiply and get negative 6. Nothing on the top changes. These two numbers just cancel each other out, and the x minus 4 comes down. That's what I'm going to deal with next. Canceling out the minus 4, you do plus 4 on both sides. Minus 4 plus 4 cancel each other out, leaving us with just the x. And then negative 6 plus 4 is negative 2. So that is our solution, or our set of solutions, really. X is all the numbers greater than or equal to negative 2. So I'm going to put negative 2 somewhere on this number line. It doesn't really matter where. I'm going to put it somewhere in the middle. Negative 2 is there. And then I'm just going to put some numbers around it to reference those. So I'm going to say negative 4 is 2 steps behind it, and 0 would be 2 steps out in front of it. And I'm going to try to draw this graph. I'm going to put a closed circle right above negative 2 because we have a line underneath saying it could equal negative 2. Or it could be all the numbers that are greater than negative 2. So we're going to have an arrow going to the right. All the numbers negative 2 and bigger. And that's what I'm going to shade here. I'm talking about all the numbers that make this true. So anything that's negative 2 or bigger than negative 2. So 0, 2, 4, 6, and 8. All of those numbers are negative 2 and bigger. Alright, example 7, we see a fraction, which could be overwhelming, but really it's the same exact steps. I'm going to box that term first, and then deal with the other part as my first step. So that plus 8 is what I want to cancel out first. I'm going to cancel out that plus 8 by subtracting 8 on both sides. Plus 8 and minus 8 cancel each other out. If you do it on that side, you also have to do it on the opposite side of that inequality symbol. So we're going to do negative 4 minus 8, which gives us negative 12. And then the sign comes down. There's a couple different ways you can handle this. You can actually multiply here. So right now this is multiplication, so it might sound weird for me to say that you can multiply here. But you can multiply by this fraction flipped upside down. If you want to, you might have been taught this already. So you might want to keep going with what you learned from before. You can multiply by this fraction flipped upside down, which is multiplying by 3 halves. I'm just going to be consistent with the way I taught it. So this would still cancel that out. And then you could multiply on that side. I'm just going to teach the opposite operation. So right now, this is shown as multiplication. So to cancel that out, I'm going to use division. I'm going to erase this. You can use that process, but I'm just going to divide away that 2/3. You do have to be careful about the way that you type this into Desmos. Actually, you want to type it exactly like I typed it, or like I wrote it there. You want to put the 2/3 in parentheses there. It's negative 12 divided by 2/3 as a fraction would give you negative 18. You could also convert that into a decimal. The only problem with that is that that's a repeating decimal. So if you're going to type this in as a decimal, you want to type a bunch of 6s. That's 6, 6, 6, 6 going on forever. If you only type in what I showed there, if you only type in 5, it's going to round that to a number pretty close to 18, but not exactly 18. So you can either type in a bunch of those, type in this fraction in parentheses, or what I showed before, you can multiply it by the reciprocal. All 3 of those work, whatever you're most comfortable with. Either way, your solution should be x is less than negative 18. So I'm going to put negative 18 somewhere on this number line. Let's start with it there, and then put a couple of numbers to reference. I'm going to say 2 behind that is negative 20, and 2 ahead of it is negative 16. I'm going to put an open circle at negative 18, because I don't have the line underneath. It actually can't be negative 18, even though that seems like that is the answer. Negative 18 is not a solution here. It's specifically all the numbers that are less than negative 18. That's why it's an open circle. It's saying it's not really that point. It's all the points to the left of that. And now this question is actually asked backwards. It's saying which numbers of this make that inequality false? Which numbers are not included in that arrow? Well, actually, negative 18 is the first one. It's specifically saying there is no dot there. That is not included there. Negative 18 is not a solution. Also, all the numbers that are bigger than negative 18, like negative 16, 0, 2, and 6, all the numbers on this side are not hit by that arrow that we drew. So those are the numbers that are going to make this false. Last example, students were asked to solve a 2-step inequality, and the work shown below, which student correctly interpreted the solution to the inequality. Let's first make sure that this is solved correctly. So I would box that for x, and then cancel out the plus 1 first. That's minus 1, that's good. Minus 1, that's good. So then we canceled out that, and then got 12 from that, so we're good up until that step. Then we have this multiplication that we're canceling by using division. That's a good step. Dividing by 4 on both sides, that's good. And we divided correctly. So x is greater than 3. That is the correct solution there. And the way I read it should give you a hint as to who's correct. Eric is saying that the solution to the inequality is just 3. That's not true. This is saying that x is bigger than 3. Actually, 3 is not even a solution. Never mind the only solution. Malachi said the solutions to the inequality are all the numbers greater than 3. Because after you solve the inequality, x is greater than 3. That's exactly how we read that. X is greater than 3. It looks like Malachi's right. I want to make sure that Aiden didn't also get it correct, maybe. The solutions to the inequality are all the numbers less than 3. No, that's backwards. X is less than 3 would look like that. So Malachi got that one correct because it's all the numbers that are bigger than 3. All right, I hope this helps.